Welcome to video lecture 31. We are going to take a look at iterators, which is a special type of object that is used to navigate containers. And we're just going to touch on the surface. We're just going to change out the for loops that we wrote in Hero Inventory 2 and put in new for loops that utilize iterators. So you see on your screen Hero Inventory 2 output after we compiled and ran it in video lecture 30. So let's take a look at the code and see how we would change this code. There we go. Okay, so I'll update Hero's inventory from the book C++ Game Programming. We'll update that to 3. There's a couple of lines in here, 8 and 9, that you haven't seen before. And I was playing around, and so just take note of those for now. Now, if vector is a container, which allows me to store string objects in the container called inventory, and use the member methods pushback to place string objects onto this or into this container at the back. So sword is first, armor is second, shield is third, mace is fourth, and that is 0 through 3 if we're subscripting into it. So we can certainly use an index into it, like, or a subscript, like in lines 24 and 25. But we can also create this thing called an iterator. And iterators work hand in hand with containers. So to declare an iterator, I'm going to say vector, the same type, only now I'm going to use the scope resolution operator. I'm going to say iterator. So that's all one big long string there. And the compiler knows that, hey, well, maybe not the compiler, but the C++ system knows that when we declare this, we're declaring an iterator. And then we're just going to give it a variable name. So then, well, I'll talk about why we would use these later. But for now, how would we change the code to use the iterator? And so the for loop is going to change a little bit. So instead of int I, basically we're going to say my iterator, and we have to initialize it. We're going to initialize it to inventory begin. And this works across all of the standard template library containers. So this gives us a more general way to code. And then for the test, we will say my iterator not equal to the end. End points to the right past the last element. And so that way, begin points to the first or the 0th object in the container, and end points to the last +1. And that way, you can create a while loop or a for loop that says while not equal to end. It's going to allow you to loop through each one of these objects, and then you'll go past the last object and you do the test, and now end is true. And so that's what we're going to do here. And then to increment, instead of incrementing I'm going to increment my iterator. And then down here, instead of the subscript notation, we will dereference my iterator, which is an object that is pointing to one of our objects in the string vector. Okay, so I'm going to compile this and see if this works. And sure enough, it works. And you might be thinking, well, what's the difference if you can do it in a loop or you can do it with an iterator? Well, the reason for doing it with the iterator rather than, and I'm sorry, they're both loops, but rather than doing it with an integer loop control variable, using an iterator gives you much more power and control over how efficient your C++ programs are. Your iterators can be passed to functions and returned from functions without triggering a copy of the entire container, which is very slow and inefficient. There's other reasons vectors are superior to using just a standard integer loop control variable, such as you can create iterators that are constant and do not allow you to change anything in the container, but it does allow you to step through the container to read it, and so on and so forth. We won't get into all of the intricacies of iterators due to the lack of time left in the class. This is the last class tonight, and so I'll just show you the very basics using the vector container and using the iterator that is understood by vector. Okay, so now I could take lines 26 and 27 and copy them, and then everywhere I see the for loop with the loop control variable, I can simply just get rid of it, replace it. Okay, so everywhere I'm looping through, I'll just go ahead and copy the iterator version and paste it in place of the loop control variable version. Okay, I think we're good. Let's give this a try. And sure enough, it comes out looking exactly the same in terms of the output.